I'm Carl Franklin. In this episode of Blazor Train, we'll compare the two hosting models, Blazor Server and Blazor WebAssembly. We'll create an app using each model and watch the network traffic in the browser. We'll talk about the maximum number of concurrent clients a Blazor Server app can handle and how to scale it to meet demands. Most importantly, we'll weigh the pros and cons of each hosting model so you can start thinking about which is appropriate for your next application. And that's all happening right now, right here on Blazor Train.
Blazor Train!
It's easy to understand the hosting model of Blazor WebAssembly. The browser downloads your .NET application as a series of .NET standard assemblies, along with CSS and JavaScript, and runs it in a sandbox. Your C# code interacts with the DOM by exchanging messages with a JavaScript handler, and that's that. The Blazor Server hosting model, on the other hand, will take the C# code part of your app and run it on the server. It seems like magic. You don't see any plumbing code. In fact, the app looks and behaves almost exactly the same as it does in a Blazor WebAssembly app. To achieve this magic, there's a little JavaScript running in the browser that hooks DOM events, such as a button click, and then it passes a binary message to the server. The server runs whatever code it needs to, and if the code has an effect on the browser's DOM, such as changing the text in a div element, the server sends a binary message back to the browser with the instructions to update the div. In order to pull this off, the ASP.NET team employed a robust messaging platform, one that would be able to maintain a persistent connection under any circumstance, one that works over port 80 and therefore doesn't require firewall rules, one that has existed at Microsoft since 2013. SignalR.
Woo, woo!
SignalR is a free and open source software library from Microsoft ASP.NET that allows server code to send asynchronous notifications to client-side web applications and vice versa. You might think of SignalR as a tool for implementing real-time chat applications, a one-to-many kind of broadcast. It's good for that, yes, but it's also good for robust one-to-one communication. In this case, each client gets a private channel of communication to Blazor Server. The SignalR hub is built right into the Blazor Server hosting model, and you don't have direct access to it. You don't see it, you can't modify it, and that's a good thing. If you need your own hub for any reason, you can just add one to your project. So let's create a Blazor Server app, run it, and watch the traffic zooming back and forth between the browser and server. After that, we'll do the same with a Blazor WebAssembly app and compare the two. I have a simple Blazor Server application called Blazor Server, and it's just the default application, so we're going to run it, and the code isn't so important right now. I actually want to show you what it looks like network-wise. So I'm going to press F12 to bring up the the browser tools and go to the Network tab. And I'm going to make sure my cache is disabled right there. And I'm going to start recording. And then I'll go to the counter page, let's say. I'm going to press Control F5, which is going to reload everything, make sure that no existing elements are going to be cached, all of that. So it's going to, just as if we came here out of the blue. All right, let's take a look down at the bottom, and you can see that only 164K was transferred. Now that's because it's a pretty, simple page, and right, there's a button and a label and not a whole lot going on. But one thing that you want to take a look at is this right here. Underscore Blazor $ID equals and then some GUID. Right, that is actually the SignalR traffic. And if you click on that, you can see the size of messages and which way they're going. Look at this. Blazor Pack protocol, right? This is a protocol that the Blazor team invented so that, it's a binary protocol to make transmission of messages, as small and compact as possible. So green means message going up, red or orange means it's coming down. And if I clear all these and then click the button, here we go. So this 3 bytes is just a sort of a keep alive, you know, hey, here I am. That happens back and forth on a regular basis. The binary message going up when I click the button is only 291 bytes. At that point, the code on the server side was executed, and then a message was sent back with 148 bytes. And what is that message, actually? Let's take a look. And this 27 bytes going back up is just sort of, okay, everything's cool. Thanks a lot. Let's take a look at this. You can see that it's just HTML, right? But then we have this @onClick increment count. How do we get from the browser back to here? Well, let's take a look at this guy, and I'll show you where he is in the list of files here. _host CS HTML. Now, down at the bottom of this, you can see there's a JavaScript file, Blazor Server JS. So when that button click occurs, okay, that JavaScript intercepts what's going on right there, and then it says, hey, the user clicked that button, sends a message up to through SignalR up to the server. Server gets the message, it executes increment count, which updates something in the DOM. Now, how do we get that back down? Well, Blazor Server has a graph of the client's DOM, of the client's document object model, all the elements that are on that page, okay, that are currently instantiated. And it executes the code against its graph and finds the difference, what changed. And it notices that this particular paragraph right here, this element, the text of it has changed. So it wraps up in that Blazor Pack binary protocol a message that says, hey, you need to update this DOM element. And then the JavaScript hooks it again, gets that message, and says, oh, well, that's got to update. So it updates the DOM. And that is essentially how Blazor Server works, by using SignalR and hooking the DOM, sending and receiving messages that are very efficient. Remember I told you it was very efficient. And everything just works magically. It's actually very, very cool. All right, now let's find out what happens in Blazor WebAssembly. So I'm going to add a new project to this solution. And we'll call this Blazor WASM. And I have to do this little trick here to get it to show up again. There we go. Now, there's a couple of options here. And one of them is progressive web application. If I check that off, we'll get all the files that we need to turn this into a PWA. We're not going to do that right now, but I am going to draw your attention to this one, ASP.NET Core hosted. And if I don't check that off, I get a single project that loads in the browser. But if I do check it off, I get an ASP.NET Core 3.1 server application with some API controllers, well, with a controllers folder in one API controller, but you can add more. And that serves the WebAssembly application to the browser. So you get a URL space, you get a server that you can call into for for controllers and things like that, for APIs. So let's do that. All right, now notice I get 3 projects here. Here's my server, right? That's going to serve this, the Blazor WASM client, which is going to run in the browser. But I also get a shared project, and the shared project is just a .NET standard library project. So this is where models go. And both the server and the client have access to them. And that's important because look at this, the controllers right here. Your API controllers need to know what those models are. In this case, it's a weather forecast controller, which is using a weather forecast model. And here's the controller right there. And the client also needs to know, because when the client calls to fetch some data, it's going to use an HTTP client to make an API call. All right? So that's important. But for now, we're going to set Blazor WASM Server as the startup project. And we'll see a whole bunch of stuff has come down here. In fact, we have 6.6 megabytes transferred. Now that's zipped or compressed. Actually, 18.4 megabytes unzipped. Well, why is it so big? Well, the reason is that the linker is turned off when you're in debug mode. So I'm going to change it to release mode. And that turns the linker on, and it will sort of stub out anything that's not being used. So the first thing I get is this little guy right here, continue debugging. I'm going to press F12, pull up the network tools again, and now we can see 2.3 megs. So that's more along the lines of what a released version of your application is going to look like, a WebAssembly application. Now, we really haven't done anything here. This is the pretty simple app, but that's sort of what you can count on as a baseline. So let's look at what got brought down here. I'm going to sort by size, and we can see that the biggest thing that was brought down is .NET WASM. So this is a native WebAssembly, mono-based, cross-platform .NET runtime. And it's only 778K. That's it. And then, of course, the rest of these are just .NET Standard 2 assemblies. Okay, let's talk about scaling. First of all, you don't need to scale a Blazor WebAssembly app when it comes to UI code. That all happens in the browser. You scale a WebAssembly app the same way you'd scale a standard web app. Use a CDN to deliver the app. Make sure that your API servers are properly scaled using containers and clusters, perhaps. Nothing new there if you've built a scalable web application before. So we're really talking about Blazor Server here. The Blazor Server is a new piece of the puzzle, and it's required just for UI interactions. And since the server is the center of the universe for your clients, there's a limit to how many concurrent clients you can have connected before performance starts going south. Not surprisingly, the two biggest factors are memory and CPU power. Microsoft estimates that you need at least 85K of RAM for every concurrent client connection. Now that doesn't take into account the data in your page, such as a list of customer objects. Needless to say, it's recommended that you avoid loading millions of objects in your pages, as that will negatively impact the number of concurrent users you can support. Besides memory and CPU power, the number of available WebSockets can also be a limiting factor. WebSockets is the primary technology behind SignalR, and most browsers support it. The number of available SignalR connections is limited by memory and CPU. However, you can completely remove SignalR from your application and offload it to Azure SignalR Service, which can scale up to support 100,000 concurrent users. There's a free version that gives you 20 concurrent users and 20,000 messages per day. The standard SKU gives you 1,000 concurrent users and 1 million messages per day per unit. You can have up to 100 units, and the cost is $1.61 per unit per day. So the maximum number of concurrent users you can have is 100,000, a cost of $161 per day. Not bad. Microsoft did a test of a Blazor Server application to see how many concurrent clients it could handle before the round-trip result of a button click took more than 200 milliseconds. That seems to be the point at which the brain considers a website to be slow and or unresponsive. They tested against a real-world application, not just a counter button. And their test simulated a button click once per second. They tested it on 2 server configurations. The first one had 1 virtual CPU and 3.5 gigs of RAM. It was able to support 5,000 concurrent users. The second server configuration had 4 virtual CPUs and 14 gigs of RAM and could support 20,000 concurrent users. And that's not even using SignalR service. That's just one box. In another episode of Blazor Train, I'll talk more about scaling Blazor Server and persisting state outside of the server, which is required if you're going to use more than one server. Let's look at the pros and cons of each hosting model, starting with Blazor Server. On the plus side, it takes less time for a Blazor Server app to load in the browser because it only requires a few files to get started. The Blazor JavaScript file, some initial CSS, and that kind of thing. You're running on the server, and that gives you a huge advantage in productivity over Blazor WASM. You can directly access resources that require credentials, such as databases and other cloud-based services. Conversely, a WebAssembly application shouldn't be able to access these resources directly. Rather, you'll need to build an API layer, which adds complexity and development time to your project. Blazor Server apps work with browsers that don't support WebAssembly, such as Internet Explorer, and on resource-constrained devices. Finally, the C# code base is not served to clients. Now, that may sound like a benefit, but I think it's moot. Whether your UI code is JavaScript or C#, it should only run code that you don't mind the world snooping around in. If you had some sort of secret algorithm that falls under the category of intellectual property, you wouldn't run it in the browser. You'd run it on the server behind an API, and Blazor is no different. On the downside of Blazor Server, there's a latency issue. Every user interaction involves an extra network hop. That goes for button clicks, checkboxes, list box selections, option buttons, any event that you're hooking in your code. It could even be every keystroke if you're putting it in an input box. There's no offline support, so if the client connection fails, the app stops working. Your clients must be connected to the internet in order to use your app at all, not just for calling APIs. So you should consider your audience when choosing the Blazor Server hosting model. Can you count on a stable internet connection? And as I already mentioned, scalability has its own challenges. The server must manage multiple client connections and handle client state. And I'll talk more about that in an upcoming episode. Finally, a server is required to serve the app. Serverless deployment scenarios aren't possible with Blazor Server applications. For example, serving the app from a CDN. All right, now let's look at the upsides of using Blazor WebAssembly. Code executes more quickly in the browser. Even though you take a hit on the first load, subsequent visits to the server will use cached assemblies. When performance really matters, you should consider Blazor WebAssembly. You can use a Blazor WASM app offline. Whether you roll your own offline support or use the progressive web app system, you can easily ensure access to cached data when offline. Blazor WASM apps can be distributed via CDN. This is important because not requiring a server saves you money in the end. On the other hand, you'll need at least one server to host APIs. Any .NET Standard 2.0 C# will run in the browser. That means any assembly compiled for .NET Core 2 or lower will run. On the list of downsides, you'll need to build an API layer if you want to access any resource that requires credentials, such as a database or other cloud service. Hey Carl, what's the current state of debugging in Visual Studio with Blazor WebAssembly? Thanks, Carl. Here's the current state of debugging in Blazor WebAssembly. As of today, May 26, 2020, Blazor WebAssembly 3.20 is now available. And you can get to the blog post, the announcement of the current availability of Blazor WebAssembly by going to release.blazortrain.com. Well, in this particular case, if you scroll down here, you'll see under the fully featured area, full stack debugging. Click on that and you go to this debug ASP.NET Core Blazor WebAssembly in the documentation. And here are all the things that you can do, and here are all the things that you can't. So essentially, you get the full debugging experience in Visual Studio, except for two things right now. Breaking on unhandled exceptions and hitting breakpoints during app startup. Those are the two things you currently can't do as of May 26, 2020. Other than that, debug away. Back to you, Carl. Thanks, Carl. Finally, some people may not want to ship their C# code to the client, and as I mentioned before, I think this is a moot point. Sensitive code should run on the server behind an API, and that's that. So by now, you should know the key aspects of both Blazor hosting models, server and WebAssembly, and hopefully you'll be able to choose the right model for your application. In the next episode, we'll dive deeper into WebAssembly. Is Blazor WebAssembly subject to the fickle fate of Silverlight? And what happened with Silverlight anyway? Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time.
Blazor Train.